As another example, we are going to solve a couple of these examples. We have an initial value, which is a0 equal to 1. And the recurrence relation an, it says you multiply the previous value an minus 1 by 2, and then you add 3. Let us find some of the terms from the beginning. A0 is given, so for the next one is a1. So a1 is equal to 2 a0 plus 3. And this is obtained from here. When a is 1, then here you will have 0 plus 3. Now, since this equation depends only on the initial value, just do not go further. Now, for the next one, a2, it is equal to a1 plus 3. And remember that this is the equation for a1 substituted here. So I will just, make a notation, a note for me that a1 should be replaced by this equation. Let us do the substitution. So this is equal to 2 multiplied by 2 a0 plus 3. And don't forget we have a plus 3 from here. You can simplify now the answer. You can simplify this answer. So this is equal to 2 to the power 2 a0 plus 2 times 3 plus 3. Now this is the symbol for multiplication times. It's not 2.3, it is 2 times 3. This is the equation that we are going to have. Okay, maybe I should move it in here, okay, as a final answer. Next, let's find a3. So a3 is equal from here, from this equation, a3, so n is a 3, it will be 2a2, 2a2 plus 3. This is the equation for a2. So substituted here. So when you substitute it, it is basically you multiply 2 by this equation. So you multiply 2 by this equation plus 3. So let us do this step in detail. So this is equal to 2 times 2 square a0 plus 2 times 3 plus 3. And don't forget we have a 3 from here. And after you simplify, 2 multiplied by 2 square, it's going to be 2 to the power 3 a0, 2 square multiplied by 3, 2 multiplied by 3, and we have a 3. How did we get this answer? So 2 multiplied by 2 square, you get this. 2 multiplied by 2, you get this. And 2 multiplied by 3, you get this, and 3 is remaining at the end. Probably we will go for one more, for 4, because we would like to guess the solution. So we will write an equation for a4. And from here, a4 is equal to what? a4 is equal to 2a3 plus 3. So a4 is equal to 2a3 plus 3. This is the value for a3. So you need to substitute it here. So basically you multiply a3 by 2. So we will do the multiplication directly. So this is multiplied by 2, this is multiplied by 2, multiplied by 2, and etc. So this is going to be equal to 2 to the power 4 a0 plus 2 to the power 3 multiplied by 3, 2 square multiplied by 3 plus 2 multiplied by 3 plus 3. Okay. Now we need to guess the solution for an. Okay. We have to look at each iteration what is the answer we are getting. Probably the last one can help you. See, this is the last one you're obtaining. If this is 4, see the first term, it is 2 to the power 4, A0. So you can guess the answer here directly. You will say that this is 2 to the power n, A0. Now for the remaining terms, if this is 4, see here you have 2 raised to power 3, 2 raised to power 2, 2 raised to power 2. If I want to make this summation in a pattern, so here I could add 2 to the power 0 because 2 to the power 0 is equal to 1. So here we have 2 to the power 3, 2 to the power 2, 2, and here. So all the terms are multiplied by 2 raised to power something, and all of them are multiplied by 3. So 3, 3, 3, 3 common. So take a 3 outside, and inside what we will have? We will have 2. Now, so notice from this equation, if this is 4, then the maximum power is 3. So let's by 1. So here we will have n minus 1 plus 2n minus 2 until we go to 2 raised to power 1 and then 2 raised to power 0. So this 2 is here, this 2 is here, this 2 is here, and the last 2 is here. And if we write it as a summation, this is going to be equal to 2 to the power n, A0 plus 3 summation k. Should start from something, and here we have 2 to the power something. We know that for the summation, k should be increasing because this is how mathematical summation. There is no decreasing one, increasing. And if you look at the power is decreasing. But I know that I can start from 0 up to n minus 1. So we can say that k starts from 0 up to n minus 1. Now what shall I put for the power? Here you have two options. Either you think about it from left to right, or you think about it from right to left. And you will see thinking about it from right to left is much simpler. Suppose I thought about it from left to right. So as a suggestion here, if k is 0, I need to get n minus 1. If k is 1, I need to get n minus 2. So by trial and error, you could try n minus k minus 1. Let us see how. If k is 0, then we will have n minus 1, which is this one. If k is 1, then we will have n minus 3 minus 2, which is this one, and etc. If k is equal to n minus 1, you are going to get 0. So this is the answer. And since we have minus in the power and we have n not related to k, so we can take them outside. So this one, I will write it in draft here, is equal to 2n minus 1 summation 2 minus k. K goes from 0 up to n minus 1. You can find the answer by the geometric sequence. This is equal to 2 to the power n minus 1, k equal to 0 up to n minus 1. Now 2 to the power minus k is in fact 2 to the power minus 1 raised to power k. And 2 to the power minus 1 is equal to half. So this is the equation for 2 to the power n minus 1 summation k equal to 0 n minus 1 1 over 2 raised to power k. Use the geometric sequence and then multiply by 2 to the power n minus 1. Okay, you will get the answer. But you can find the final answer without all these complications. So instead of this, I'm going to change the summation, and we will look into the answer from right to left, not from left to right, not from left to right. So an, I will use different color for the changes. An is equal to the power n, a0 plus 3. Now here we will write a summation in a green color because I'm going to use this one. And again, it will start from 0 up to n minus 1. But we will look at the numbers 2 to the power n from right to left. So the first number is raised to power 0. Second is 1. And then until we go to n minus 1. So simply this is going to be equal to 2 to the power k. So see how simple the summation is. But if you look at it from left to right, you're going to have this complicated summation, though both of them will give you to the same answer. So try to simplify here. Apply the geometric sequence on half. So it will be half raised to power n minus 1 over half minus 1. And then multiply it by 2 to the power n minus 1. You will see that it will be equal to this equation. So let us continue now. This is equal to 2 to the power n a0 plus 3. Now the geometric sequence for this sequence, it already starts from 0 and it raised to power n minus 1. So the answer for it is direct, multiplied by 2 to the power n minus 1 over 2 minus 1. Given in the beginning that a0 in the beginning is equal to 1. See, a0 is equal to 1. So by substitution, we will have 2 to the power n multiplied by 1 plus 3 multiplied by 2n minus 1. If you stop up to here, we will accept it as a final answer. But if you want to simplify it further, then so I will just put a cloud around it that this is the final answer. And if you want to simplify it further, then this is equal to the power n 3 multiplied by 2 to the power n minus 3. And if you combine these two together, 2 to the power n, it will be 1 plus 3 minus 3. This is equal to 4, and it's equal to 2 to the power 2. So this is equal to the power n multiplied by 2 to the power 2 minus 3. So therefore an is equal to the power n plus 2 minus 3. So if you want to use Wolfram alpha, this is the answer that you are going to get. But you don't need to simplify it further. If you reach that up to this step is acceptable, because I know that you are following the steps correctly, so there is no need to waste your time for the simplification. So this is how we solve recurrence relations by forward chaining or forward iteration.